All right, a word problem. Example number 4. It says a picture that measures 10 centimeters by 5 centimeters is to be surrounded by a mat before being framed. So here's our picture inside. And then we're going to frame the picture, but the customer wants to put a mat around the picture. The width of the mat is to be the same on all sides of the picture. The area of the mat, so the area of this is going to be twice the area of the picture. What is the width of the mat? Okay, so a little tricky. What we want to do is we want to come up with an area for the entire frame. And in order to do that, that is going to be the area of the picture plus the area of the mat. Okay. All right, so to get the area of the entire picture, I'm going to take the area of the picture, which would be length times width, which would be a 5 by 10. And then the area of the mat is going to be twice that size. So I'm going to add this to 2 times 5 by 10. So the area of our entire frame, if I added these two values together, is going to be 150 centimeters squared. All right, so now in order to write, now we want to figure out, well, what is the width of this mat, right? So in order to figure that out, we want to come up with an expression that relates to the area of this entire framed picture. So when I look at this entire length from here to here, this length would be 10 centimeters plus a width on this side plus another width on this side. So this is going to be 10 plus 2w, or 2w plus 10. Same with the width of my entire picture. This is initially 5 centimeters, and I'm adding a width here and adding a width here. It would be 5 plus 2w. So I know the area of any rectangle is length times width. I know my area of this entire frame picture is 150. The length of my entire picture would be 10 plus 2w, and my width would be 5 plus 2w. So now I have a quadratic equation where I can solve for w. So in order to do that, we'd have to expand this through by foiling this. So when we do that, we get 50 plus 20w plus 10w plus 4w squared. Collect our like terms. Okay. And so now we have a quadratic equation where we need to solve for w. Well, in order to do that, we have to make our equation equal to 0. So I'm going to bring 150 to this side. At the same time, I'm going to write this in the order that we generally like to see things. So 4w squared plus 30w, and then this is going to be minus 100. All right, so now we are ready to solve this. So how do we solve this? We've learned two methods now algebraically. One is factoring, and 2 is completing the square. Factoring is a way more efficient method than completing the square. So if it can be factored, that's the method we want to go with. So let's try and factor this. So I have a common factor out of all this. So I'm going to factor out a 2. I'm left with 2w plus 15w minus 50. By doing that, working with smaller numbers, it's easier to figure out your factors than necessarily working with these larger ones. Okay. So to factor this, my factors would be 2w and w. And then if I multiply the 10 by 2, that gives me 20 minus 5. 20 minus 5 is 15w. So this needs to be a plus 10 and a minus 5. So positive 20 minus 5 leaves me with 15w. Okay, so when we go to solve this, even though 2 is a factor, is actually, we don't need to consider it when we're actually solving the equation because it doesn't have a w or variable attached to it. So we're just going to ignore that, and we're going to solve these two factors for w. So w would be 5 over 2. Bring 5 to the other side is positive, divided by 2, which is 2.5. And my other solution would be negative 10. Well, because we're talking about the width of this mat, which talks about distance, we can ignore this negative value, and the width of the mat is going to be 2.5 centimeters. Therefore, the width is 2.5 centimeters.